Orbiting the magnificent gas giant planet Jupiter is the mysterious icy moon, Europa, a seemingly frozen world about the same size as our moon. With a surface temperature of about -160 degrees Celsius, -256 degrees Fahrenheit, and a location that means it has to withstand a relentless pummeling of radiation. At first sight, it would be easy to think of Europa as a barren ball of ice. But despite the harsh conditions it exists within, this fractured moon is one of the most promising places to search for alien life. So how could life survive on such an extreme moon? And if it does exist, what might it look like? You are watching Cosmic Exploration. My name is Rob. And if you enjoy my videos, then remember to subscribe and tap the notification bell to never miss an upload. Many spacecraft have passed by Europa during their missions, but it was NASA's Galileo spacecraft that elevated our understanding of this icy moon to a new level. It discovered the first solid evidence that an enormous ocean exists beneath its surface. An ocean with possibly 2 or 3 times as much water as all of Earth's combined. Arriving at the Jovian system in December 1995 with the aim of exploring Jupiter and its large moons, Galileo passed by Europa multiple times, coming as close as 201 kilometers, 125 miles. It captured its frozen terrain in incredible detail, allowing us to see close-ups of its cracks, ridges, and jumbled-up landscape, but also find intriguing evidence of what might be happening below its crust. Galileo confirmed that Europa was geologically active. Its close-up images revealed the enormous cracks in the moon's surface had separated, and dark, icy material had flowed into the opened gaps. As with the spacecraft that came before it, Galileo also found only a handful of impact craters, which are expected to build up over time as the surface is constantly bombarded by meteorites over billions of years. Much like our own moon, for example, but Europa is smooth, suggesting that its surface is relatively young and that something had erased any large craters, such as icy volcanic flows. One of the most important measurements made by the Galileo mission, however, showed how Jupiter's magnetic field was disrupted in the space around Europa. This measurement strongly implied that a special type of magnetic field is being created within the icy moon by a deep layer of some electrically conductive fluid. Based on Europa's icy composition, scientists think the most likely material to create this magnetic signature is a global ocean of salty water. There are even images from the Hubble Space Telescope that appear to show huge plumes of water vapor erupting from Europa's south pole, although, unfortunately, they are not high-resolution enough to be definitive. But if Europa's surface is frozen solid, then how could a massive ocean of salty water form? And, if there is liquid water down there, could life have really started in such a bizarre environment? While the icy shell of Europa is clearly frozen as hard as a rock, the interior is warmer because it is heated by what's called tidal flexing. The side of Europa that's closest to Jupiter experiences a stronger pull than the other side, stretching the entire moon back and forth, probably causing the long cracks that run across its icy surface, as well as heating the interior through friction. Similar to how repeatedly bending a paperclip generates heat, for example. It is this constant flexing that melts the internal ice and creates Europa's enormous ocean. But is it really possible for life to start on a frigid moon, hundreds of millions of kilometers away from the sun? Well, life as we know it seems to have 4 main requirements: liquid water, certain chemical elements, an energy source, and, of course, time. We have already discovered that Europa may have an enormous ocean of liquid water that is protected below its crust. And certain studies of the ocean have suggested that it may have formed just a few 100,000 years after the moon formed, which is estimated to be around 4.5 billion years old, giving life, if it does exist there, plenty of time to get going. In addition to considering the necessity of water, it's crucial to address the other 2 requirements for life as we know it: chemical elements and an energy source. Chemical elements serve as the fundamental building blocks of life, and they encompass a range of elements including carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These elements are not only prevalent throughout the universe, but also constitute approximately 98% of living matter on Earth. Through their combination, they form organic molecules essential to life's processes. In the context of Europa, scientists speculate that these essential chemical elements were likely present during the Moon's formation. Furthermore, they posit that additional elements may have been introduced over time as a result of collisions with asteroids and comets. Recent observations, such as those made by the James Webb Space Telescope, have provided intriguing insights into the chemical composition of Europa's surface. For instance, the telescope detected significant amounts of carbon dioxide, represented as white patches in infrared imagery of the Moon. This discovery suggests the presence of carbon, a vital element for life, likely originating from the subsurface ocean beneath Europa's icy crust. Understanding the distribution and abundance of chemical elements on Europa offers valuable clues about the Moon's potential for hosting life or supporting the conditions necessary for its emergence. As we continue to explore celestial bodies within our solar system and beyond, uncovering the presence and dynamics of these fundamental elements remains integral to our quest to understand the potential for life beyond Earth. Then we need an energy source. All life as we know it requires it to survive. Here on Earth, life relies mainly on the sun for energy, such as through photosynthesis. Plants convert sunlight into energy, allowing them to grow, and that energy is then transferred to those who eat the plants. But any life that may exist in the ocean of Europa is hidden below the thick ice. No light can penetrate through it, meaning that a process like photosynthesis couldn't work. Instead, life would have to be powered purely by chemical reactions. And these reactions could come in multiple ways, such as from Jupiter's powerful radiation, perhaps that is bombarding Europa's surface, or more likely from the warm rock on the sea floor. As the icy Moon orbits around Jupiter, its interior flexes as we have already discovered. The flexing forces energy into the Moon's interior, which then seeps out as heat. The more the Moon's interior flexes, the more heat is generated. If Europa's rocky ocean floor is heated by tidal flexing, that process could potentially be supplying energy in the form of available chemical nutrients in hydrothermal vents. And this type of process can be seen here on Earth, where life is abundant. The vents are like bubbling cauldrons of energy, spewing out superhot water that has flowed below the Earth's surface, becoming heated by a layer of molten magma. They erupt with plumes of what looks like smoke bellowing out of a chimney, but within it is a soup of chemicals that certain life can thrive on. The chemicals would be toxic to human beings, but these organisms can convert the chemicals to energy. This process is called chemosynthesis and is what ultimately powers entire ecosystems around hydrothermal vents found in the deep, dark regions of our oceans, the places where the sun's light cannot reach. The vents are the only places on Earth, in fact, where the ultimate source of energy for life is not sunlight, but the Earth itself. Huge red-tipped tube worms, ghostly fish, strange shrimp with eyes on their backs, and other unique species thrive in these extreme deep ocean ecosystems. So life as we know it on Europa, it seems, could be possible, but what might it look like? To get an idea, one place we could look is within one of the deepest, darkest points on Earth, the Mariana Trench. The deepest point in the Mariana Trench is called the Challenger Deep, and is 11 kilometers, 7 miles below sea level. It is difficult to comprehend how deep that actually is, but if you placed Mount Everest there, the peak of the mountain would still be more than 2,000 meters, 6,561 feet, below sea level. However, that's nothing when compared to Europa's ocean, which is anywhere between 60, 160 kilometers, 40 and 100 miles deep. Despite this enormous difference in depth, however, the conditions between the two environments may still share some similarities. Imagine a vast, seemingly endless, pitch-black void filled with crushingly cold seawater. This is the type of oppressive environment life within the Mariana Trench has had to adapt to. But dive deep enough, and you will find some of the weirdest creatures on Earth. Creatures so strange that you would think they were from Europa. Take the snailfish, for example, a species that breaks the record for any living vertebrate. It is the deepest living fish ever discovered, found at more than 8,000 meters, 26246 feet, below sea level. This weird, translucent, tadpole-looking fish is known to contain chemicals which help keep its membranes and cell walls flexible so that the crushing pressure doesn't kill them. But there are creatures that live deeper. Within the deepest region of the Mariana Trench, the Challenger Deep, three organisms are most commonly found. The first are called xenophyophores and are the world's largest living single-celled organisms that resemble spherical or frilly sponges, about 20 centimeters across, 8 inches. In the enigmatic depths of the ocean, where light struggles to penetrate and pressure reaches staggering levels, a fascinating array of creatures defy conventional understanding to survive in extreme conditions. Among these are peculiar organisms, whose methods of survival offer tantalizing insights into the resilience and adaptability of life forms in the deep sea. Firstly, there are the mysterious creatures that seem to thrive amidst the darkness and crushing pressure of the ocean floor. While their exact mechanisms of survival remain uncertain, scientists hypothesize that these enigmatic beings produce a viscous slime that permeates the sediment around them, serving as a means to capture and absorb microbes vital for sustenance. This remarkable adaptation underscores the ingenious strategies that organisms employ to eke out an existence in the abyssal depths. Another intriguing denizen of the deep seas is the amphipod, a diminutive, shrimp-like scavenger that defies the inhospitable environment through the remarkable properties of its exoskeleton. Composed of chitin fortified with aluminum, these exoskeletons provide crucial protection against the immense pressure of the ocean depths. The mystery of how these creatures acquire and utilize aluminum remains a puzzle, yet scientists speculate that they harness specialized sugar-based chemicals within their digestive systems to extract aluminum ions from the seabed as they scavenge on detritus raining down from above. Lastly, the realm of the deep sea is also inhabited by the otherworldly holothurians, a species of sea cucumber that adds an additional layer of strangeness to this alien environment. With a diverse array of forms, ranging from spiky, brightly colored specimens to those adorned with smooth, translucent skin, these creatures navigate the abyssal plains with an eerie grace. In recent explorations of the Mariana Trench, vast fields of sea cucumbers have been discovered, evoking images of grazing cattle meandering across terrestrial pastures, feeding on bacteria and decomposing organic matter littering the seafloor. These holothurians play a vital role in the ecosystem dynamics of the deep sea, further emphasizing the rich diversity and complexity of life in this extreme environment. As scientists continue to unravel the mysteries of the deep sea, each discovery offers a glimpse into the astonishing adaptations and survival strategies that enable life to flourish in the most inhospitable corners of our planet. So if life has managed to thrive in the deepest oceans of Earth, could it have also done the same in the even deeper oceans of Europa? Until we send a probe capable of drilling through the thick layer of ice that encases it, we may never know. Europa could be full of alien creatures, or it could be completely barren. However, that burning question may be answered in the next few years. Because the European Space Agency along with NASA each have two separate major missions to Europa. The first from ESA is called JUICE and has already launched in April 2023, arriving in 2031 for a double flyby with the aim of collecting new data on the chemistry of the icy moon. Then we have NASA's Europa Clipper, which is a mission designed to determine once and for all whether this icy moon's ocean is habitable or not. It is scheduled to launch in October 2024, but won't arrive until April 2030. The exciting missions should complement each other, but neither will be able to confirm if aliens exist here, just whether the icy moon has the right conditions to support life as we know it. If we did eventually find some form of life on Europa, it would probably be in the form of microbes, surviving around a hydrothermal vent. But if it can be demonstrated that life formed independently, regardless of how complex it is, in two places around the same star, it would then be reasonable to suggest that life springs up fairly easily once the necessary ingredients are present, and that life might be found throughout our galaxy and the universe. I hope you enjoy this video. If you did, then tap the like button and subscribe. There is plenty more to come. Thank you for watching, and I'll see you next time.